Very good morning, students. I welcome all of you to this diploma training CET classes. So, this diploma CET 2020 in association with MIT Thandavpura and MIT Mysore. Myself, Professor Rajesh A.S., Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Thandavpura. So, here in this session, I'm going to cover all these topics like lathe and its operations, drilling machines and its operations, milling machines and operations, along with a small topic of plant maintenance. So let me start with the machining process. So what is machining? What are the different types of machining processes are there? So here this machining is a term which is used to describe a variety of material removal process. So where to get a desired shape of a workpiece, we must have to do certain operations on a workpieces to get the desired shape. So out of which there are plenty of machining operations are there. So here we have lathe operations, drilling operations and milling operations are the most important point of concern. So what are the different types of machining processes are there? So there are different types of machining processes are there. Before going to that, what are the main important components of a machining process or elements of a machining process? So here there are three major important elements are there in a machining process. The first one, obviously, machine tool. So machine tool is a machine tool is a one thing where exactly actual machining process is carried out. So another one is workpiece. So here we should have a workpiece to do the machining operations upon which we are going to do a certain operations. And the third one, most important one, cutting tool. So the tool which is used for cutting operation, it is a cutting tool, be it a single point cutting tool or multi-point cutting tool. So these are the three important elements of machining process. So let us start with a lathe machine. So actually lathe is the oldest known machine tool to all the mechanical engineering science. So here it is a machine tool which holds the workpieces in between two rigid supports to do the operations. Usually circular objects will be made from this machine. Actually it can be also used for tapering, taper turning and facing, drilling, boring, spinning, grinding and polishing operations, etc. So let us have a look of this lathe machine and its various component. So here lathe and its various component. You are looking at this image where this is a lathe machine. You can see here are different parts. So variety of parts are there here. So here tail stock is there, head stock is there, and cutting tool, cutting post is there. Everything is there. So lathe machine, it is just appears like this. It is a mother of all the machine tools. So we can do any type of operations on this machine. So then what are the important elements of this lathe machine? So lathe bed, lathe base, headstock and gearbox, spindle, chuck, tail stock wheel and carriage, cross slide and tool post and compound rest, apron, feed rod, lead screw, split nut, etc. So here we can see all these things here itself. So lathe is a machine tool which can have a provision for doing any type of operations on which this. So it is a very oldest known machine tool to this mechanical, and we can obviously 90% of all the machining operations can be done with the help of this the lathe machine. So these are the important parts. So let us go through the lathe operations. So what are the different kinds of operations can we do here? So turning, the first one is turning. Turning is a machining process used to make cylindrical parts in which the cutting tool moves in a linear fashion while the workpiece rotates. Means this is, you can see this picture here, the workpiece is rotating and the cutting tool is moving. So feed direction fed against to the 90-degree means perpendicularly the tool is fed against to the workpiece to remove the unwanted material. So by which we can reduce the diameter of a bar or rod or whatever it may be, the workpieces, right? This is turning operations. So next one, taper turning. In many cases, we don't want same cross-sectional area workpiece. where we should have a tapered area. Tapered area, you're seeing like this here. Tapered area means at the one end of the workpiece the diameter will be large, and at the other end it is a very small diameter. So tapered turning is also a lathe operations where this is carried out under a lathe machine to produce a conical shapes, or to produce a tapers or a cylindrical shapes of varying cross section. So this is one of the example. So here in a taper turning we have two types. We have two types. The first one, taper turning by setting over the tailstock center, means either I can mount a workpiece in a lathe axis and I can change the tool, or I can fix the tool and I can tilt the workpiece. Either of the way I can get it the taper of the workpiece. So here this is the first one. Here you're seeing this. Looking at this image, we can say, so the cutting tool, it is exactly in the position, but the workpiece is get tilted for some angle, right? So here workpiece is get tilted for some angle, that is offset. So offset is given to this, and we are going to obtain the taper. And here by swelling the compound tool rest, means we are going to swell the compound tool rest itself. So by to obtain the tapered object. So what are the different types of lathe? So different types of lathe includes engine lathe, special purpose lathe, automatic lathe, turret lathe, and computer control lathe. So let me speak few things about this. So in a olden days, what we are using, it is all about engine lathe. It is a very big when compared to this, it takes or it occupies a space of this room, right? It's a very big one. Now all the designs are well compacted, so it is come to very small and robust design. So I can say this is a robust design of machines are come into picture. That is even that is controlled by computers. So where along there are human beings are here to do a certain type of operations around which, let me take a simple example. When a single lathe is there, there are plenty of people are working around the a single lathe. But now this concept is nowhere, where a single human being is enough to manage all the different types of lathe or milling machine or grinding machine. Means the technology take all the conventional type of systems, right? Advancement of technology take all these things. So let me speak about engine lathe. It is the oldest lathe in a beginning era. We are going to do all these things. And after this, special purpose lathes. So here, as the name itself implies, special purpose. Here you can see turret lathe, engine lathe, and then computer control lathe. Yeah, this is the advanced lathe where we are using this. The each and every machining operations is carried out with the help of computers and its programs. So here, simple example for this, in a long back, 10 years down the time, people are used to load the material into the machine and then they have to do the machining operations manually. But now there is no such concepts. So if we feed the program into the computer microcomputer, here it is in a computer controlled lathe or CNC lathe, and each and every activity will be well defined in the program itself. Every such activity will be taken care by the help of a CNC machine itself. So no human being is required at all to do the machining operation, but he is required to do the certain operation like loading, unloading, and feeding the data into the machine, etc. That's all. So this is all the advancement of lathe machines. So here special purpose lathe, it comes to do the special activities of a machining process. Automatic lathe, it is also one kind of lathe which is used to do the operations that cannot be easily done by conventional lathe machines. And computer control, it is already CNC machines. So all the types of lathe machines are look similar, but it does the different kinds of works. That is why all are different name. So next concept is a theory of metal cutting. So when we start cutting a metal, obviously there are certain things need to be considered. So the first one is, when we start machining operation, obviously cutting tool is the one and workpiece is the one, and the third one is machine tool. These three things will come into picture. The next one, how exactly the material will be removed, whether it is removed in the types of chips or it is removed in the types of any other form or whatever it may be. It's also affect the surface finish of a product or a workpiece, right? So here chip finishing or chip formation is all about machining and gradual removal of a excess material from the performance blanks or the in the form of a chips. When we start doing some kind of machining operations, obviously the workpiece is get in touch with the cutting tool. So when the cutting tool start doing its operations, either in the form of a chips or any kind of a powders, it start getting shaped. So these type of chip formation will follow certain mechanism. How exactly this followed, whether be it a different kind of mechanism or any other form, will look in the next slides. So majorly the surface finish of a product or a workpiece is depend on type of work material which is used. And the second one, the geometry of a cutting tool. It is most important topic and the most important aspect in this metal cutting, because the geometry of a cutting tool decides the quality of a product. So the next one, cutting velocity and feed and depth of cut, it is also very important. And machining environment. Machining environment, it is nothing but whether this entire machining operations is carried out under laboratory conditions or at the shop floor conditions or at any evacuated situations where any other kind of things are required or not. And the type of cutting fluid or a lubricant or coolant used in the system. So these are the main important aspects while we machining any kind of material with the help of a cutting tool. So types of metal cutting process. So here we can come across with the two different types, orthogonal cutting and oblique cutting. Orthogonal cutting is nothing but orthogonal 90-degree cutting or two-dimensional cutting. The cutting edge or a face of a tool, it is 90-degree to the line of action or a path of tool or cutting velocity vector. Means here there is only two forces are acting apart, were acting upon the cutting workpiece. When the cutting edge or a face is exactly perpendicular to the workpieces, that is called orthogonal or 90-degree cutting or two-dimensional cutting. Oblique cutting. Oblique cutting, it is nothing but three-dimensional cutting. The cutting edge or a face of a tool is inclined at an angle less than 90-degree. So when we are performing certain operations, when the tool and the workpiece is inclined exactly at a 90-degree, then we call it as a orthogonal cutting. When we say less than 90-degree between the tool and workpiece, obviously it's a oblique cutting process. So most important is cutting tool. So it is one of the element of a machining operations. The first one machine tool, second one workpiece, and the third one cutting tool. So I must have a fair knowledge of this cutting tool so that I can select a proper cutting tool to cut the workpiece. Let me take a simple example. So if I take a workpiece of very hard material and if I choose a wrong cutting tool, then it won't happen. Means machining won't happen. So that I must have to select a wise or a very good cutting tool to cut the different types of workpieces. Not all the cutting tools, not a single cutting tool is enough to cut all the workpieces. Different types of cutting tools are used to cut the workpieces required by the operations. So here cutting tool or a cutter, it is a tool that used to remove the material from the workpiece by shear deformation. Okay. So here we come across with two different types of tool, single point cutting tool or multi-point cutting tool. Whether single point cutting tool means, as the name itself implies, a point of contact between the workpiece and the cutting tool. It is just a single point, line contact or a point contact or a surface contact enough. Andre in a very single point or only one point is come in contact with the workpiece to remove the material. Multi-point cutting tool. Multi-point cutting tool is nothing but, as the name itself implies, there are several points. More than one point is helping out the cutting operations. That is called multi-point cutting tool. For example, drilling, milling, broaching, shaping, etc. Okay. So here you are. These slides explain about nomenclature of a single point cutting tool. So here single point cutting tool is a very most important tool which is widely used in lathe machines, turning operations. For all turning, taper turning operations, facing operations, knurling operations, every kind of this will follow this. And here, so you can read this diagram: front view and top view and side view. So here, this is, you can see a shank. It is a solid bar which holds the workplace tool holder, and face, nose radius, cutting edge. You're looking at this cutting edge. This cutting edge is come in contact with the workpiece, right? So this is the three different views of a single point cutting tool. Okay. And next, cutting tool material. What are the different types of cutting tool materials are available actually in the industry? So we might have not known all these things. So I cannot use all types of machines, all types of material that are available on the earth. Any kind of cutting tool should possess some kind of characteristics. Then only I can go and select, yeah, this is best to cut this type of material. Until unless if that doesn't possesses some kind of characteristics, I cannot go to the selection of a cutting tool material to cut work pieces, right? So these are the very limited cutting tool materials are available on this today's market to cut any kind of material. We can cut any hardest known material. So what is the hardest known material on the earth? Polycrystalline diamond. Polycrystalline diamond is the hardest known diamond, or even now on a present day research is ongoing on a single point or a single crystal diamond. It is the most hardest known material ever on the earth. So even we can cut this single crystal diamond also. Then think about the technology which takes all these things. So the first one, cutting tool material, carbon tool steels. In a long days we are using we are relying on the carbon tools. So after that we come into the high speed steel. So high speed steel is the most widely used cutting tool in the field of machining industry, all over this all over this manufacturing scenario. And cast alloys, carbides and ceramics and cubic boron nitride and PCD diamond, polycrystalline diamond and single crystal diamonds. So looking at this slide, so if we start from carbon tools till the single point cutting diamond, so the hardness goes on increasing. Means carbon tool steels have a less hardness and single crystal diamond have a very good hardness. And here greater toughness means if I start moving from bottom to top, the toughness is goes on increasing. Toughness is goes on increasing means single crystal diamond possesses very less toughness. It is a very brittle material. It can break up the sharp breakage. So the another topic is tool wear. Tool wear means obviously when any two metal pieces are come in contact with each other, wear is a common phenomena. It is just a gradual failure of a cutting tool due to regular operations. If we keep on using the same cutting tool for a longer period of time, obviously a tool wear will occur, right? So means losing of the efficiency or losing the efficiency of this cutting tool over a period of time. Okay. So generally, why this cutting tool or a cutting wear, cutting tools are fail? Either by mechanical breakage due to excessive force and shocks. So if I apply a large amount of forces to cut the workpiece, obviously cutting tool will fail. And second one, quick dulling of a plastic deformation due to intensive stress and temperature. If I performing a machining operations at the highest temperature, then obviously these cutting tool will melt itself. Plastic deformation will happen. And the last one, gradual wear of a cutting tool at its flank and rake surfaces. Means, obviously, this is one such common phenomena where with a usage of cutting tool for a certain period of time, obviously, wear will occur due to friction. Friction that exists between the cutting tool and a workpiece will causes this wear. We can eliminate all this type of tool wear by taking utmost care during the machining process by providing a cutting tool, cutting fluid or a lubricant, or we can do the machining operations at a lowest speed, feed and depth of cut, and taking utmost care we can easily eliminate the tool wear for a certain period. We are not, I cannot say avoid 90%, we cannot avoid this. 10% we can minimize the effects. So tool life, obviously this is a challenge for every one of us to improve the tool life. Tool life generally indicates the amount of satisfactory performance or services rendered by the fresh tool or a cutting point till it's declared failed. Means when I say this life of a tool is very good, I can indicate this as in a minutes. Tool life, it's usually expressed in terms of minutes. Means I can do the machining operation for 2 hours or 3 hours or 4 hours, etc. Means how effectively the life of a tool is come, or how effectively the tool is performed. It is nothing but tool life. So what are the different types of tool what are the different types of factors that infects on the tool life? So cutting speed, if I increase the speed, obviously the tool life will be less. Feed and depth of cut, if I increase the depth of cut and feed rate, obviously the tool life will be decreased. Tool geometry, we must have to select a very good geometry. And tool material, so tool material means if I cut, if I want to cut a hardest material, I must have to take a cutting tool that is double the harder of the workpiece, isn't it? So if not, the cutting tool itself fail. That is tool material. And next one, cutting fluid. So during cutting operations, I must have to take a cutting fluid which helps to reduce the temperature at the cutting zone, and which helps to reduce the friction that exists between the two metal pieces, and which carry away the chips that are coming out of the process, and workpiece material obviously, and rigidity of the work and tool machine, etc. So these are the very few factors that affects the tool life. And next one, cutting fluid. Cutting fluid means lubricant or coolant or any kind. So cutting fluids, it is just a type of coolant or lubricant designated for metal working processes. Which, what is the purpose? Why we are going to use this in a machining process? The most important functions of this cutting fluid at the machining operation is to reduce the temperature. Is to reduce the temperature at the machining zone. And second one, which helps for easy machining operations. Easy machining operations, here there is no difficulties which come across with the machining process. And third one, so cleaning of the machining zone. So while the cutting tool cuts the workpiece, obviously the parts will come out as a chip will be formed. These chips will be cleaned away by the cutting fluid. And protection of a nascent finished surface means which improves the surface finish, that is why we must have to use a cutting fluids. But now on this present day, we can have a provision for dry cutting also. Dry cutting processes are also available in this technology. So what I can say is, if we have a very good technology updating from day to day, which affects the quality of a product, quality will be improved. So now I can essential properties, I can tell what are the different types of or different qualities are there. Different qualities of cutting fluid to be chosen by the process. The first one, high specific heat. high film boiling point, friction reduction, chemical stability, and less volatile and high flash point, resistance, and odorless, non-toxic, and easily available and low cost. These are all the essential properties or desirable properties of a cutting fluid which is used in the machining operations. All such cutting fluids that are used in the system that must have these properties. If not, I cannot simply use any kind of material or any kind of liquid or lubricant to machining operations. I cannot simply use the water as a lubricant, right? So it corrode the metal pieces. I cannot use a grease always on the work surfaces. Means a different types of cutting fluids are available to cut a different types of material. So this is all about lathe machine. So let me speak something about drilling machine. You might have seen these drilling machines in the daily life. So, or where you go for a fabrication shop, you can find lathe machines and drilling machines and milling machines, everything. So, drilling in that, I can say drilling is a operations which is performed on a solid object to create a holes, to create a round holes or to create any different shapes of holes with the help of a drill bit. You can see here, this is a work-based material and this is a drill bit or a drill tool. And this feed motion, the workpiece is laying on the surface and the cutting tool is feeding upon the workpieces to create a hole. So this is drilling operations. The tool which is used in the drilling operation, it is called drill bit. So here where you can see this is a drilling machine. So in a drilling machine, drilling is a operations where we are going to create a different shapes on different sizes of holes at the workpieces. So we have many different types of drilling machine: vertical drilling machine, horizontal drilling machine, portable drilling machine, etc. So in a daily life, what we are using is, it is all about portable drilling machine. So you might have seen in a wood cutting operations, carpentry work, a human being is always used to make a hole in a wood, right? It is a portable drilling machine. Yeah, this is what a drill bit or a tool which is used in the drilling operations. So shank, it is a holding, and then flute.